Okay, so this problem is asking us to write the linear combination of the cosine and the sine function as a single cosine with a phase displacement. So if you're in pre-cal right now and you're learning how to write the linear combination of a cosine and a sine, you should have recognized almost immediately that this equation could be combined, or these two sinusoids can be combined into a single sinusoid. So we're going to talk about how that's going to work. The new sinusoid is going to take this form: a times cosine of x minus d. Now a is the amplitude, d is the phase shift, and I'm about to show you exactly how to calculate both of those. So to calculate a, it is just regular Pythagorean theorem. Maybe we can talk about y some other time. So we're going to note that this is a and this is b. So we're going to get square root of 12 squared plus 5 squared. That's 144 plus 25, which is 169. Oops. And so the amplitude of our new sinusoid is going to be 13. We're going to hang on to this number. Okay, so to calculate d, the phase shift, it is going to be the arctan of the sine coefficient b divided by the cosine coefficient a. Now you also need to keep in mind that the sign for a and b, by sign I mean positive or negative, so the sign attached to a and b are relevant. So you need to evaluate the arctan and figure out which quadrant the real answer is going to be. So we're going to get an arctan of 5 over 12. Now keep in mind the cosine value is positive. So we have a positive a, and the sine coefficient is also positive. So the arctan, or the angle, that we're going to get is in quadrant 1. I would just encourage you to think about this, because if a and b were both negative, we would still get a positive arctan, or we would still get a positive argument for arctan, but the actual angle that we would need to come up with would be over here in quadrant 3. Actually, what I'm going to do is draw you a little map. So your a value, that's the cosine. So over here you have positive a. Where is the cosine positive, or the coefficient? And then you have negative a values over here on the left. And then you have positive sine values this way. And you have your negative sine values this way. So if a and b are both positive, you're talking about quadrant 1. If a is negative and b is positive, you're talking about quadrant 2. If a and b are both negative, that would be quadrant 3. And if a is positive and b is negative, that's going to be quadrant 4. So just be careful when you're doing the arctan. That's what I'm getting at here. So now what we're going to do is evaluate this arctan. For us, since it's going to be quadrant 1, we can just do regular inverse tan. I'm going to make sure that I'm in degree mode. And then we do inverse tan 5/12. We get 22.62 degrees. Kind of a weird number. That's okay though. I wasn't expecting a whole number here. So our single sinusoid is going to be 13 cosine of theta minus 22.62 degrees. And this will be our answer.